Okay, in this video we are discussing the type of the solutions or the type of the roots based on this auxiliary equation or characteristic equation, and this is the type of solution. And we have the differential equation a y double dash plus a y double dash plus b y dash plus c y equals to 0. So this is a quadratic equation. So the solution must be based on this discriminant b square minus 4 into a into c. So case 1 is, because it's a second order differential equation, so we have two roots, that is one is m1 and the other is m2. So case number 1 is that if the roots are real and distinct, real means that real number and distinct means real. One more thing, real is, for example, m1 is 2, number 2, and m2 is minus 5. So these two are real, and distinct means different. These two are you can say unequal roots. So if these two are unequal roots, then what will be the solution? I'm not discussing all the story behind this general solution. I'm just saying that you just have to look at the type of m1 and m2 and you apply the general solution directly. So its general solution is, say its general solution YC, that means complementary solution. Complementary is for the homogeneous type of higher order differential equation. So based on 2, it's a linear combination c1 e to the power m1 into x plus c2 e to the power m2 into x. So that is the general solution of this 2 if we have m1 and m2 real and distinct. And also one more thing is that you have to check that these two functions, e to the power m1x is a function and e to the power m2x is another function for the second order differential equation. So you have to check that these two functions must be linearly independent functions. Very important point in that. So here is case number 1, and if you have case number 2, case number 2 here is real but repeated roots. That means if you have second order differential equation like this, and if m1 is equal to m2, then what you have to do, which type of solution should be? The solution should be complementary solution or general solution should be. I'm not discussing the science behind that, because the science behind that in this repeated real roots is reduction of order. So that's a long story. So I'm not discussing. You just have to apply this technique. So c1 e to the power m1x, either you can substitute it totally in terms of m1 or you can substitute m2 totally. Okay, m1, if I write it completely in the m1 form, then c2 multiply it with x into m1 into x and m1 into x. So that will be the general solution. So I told you the logic behind that is the reduction of order. If we have time, then we will discuss its story, that how we write this x in the repeated real roots. Alright, so that is case number 2. If you have repeated roots, then you use this general solution. And also this is only a one function, so I cannot say it's a linearly independent or dependent function. Okay, we move forward into case number 3. If you have complex conjugate roots, that means now it is not real. That means it is imaginary numbers are, you know that of which type. m1 is a plus alpha plus iota beta, right? And m2 is conjugate. Conjugate means alpha minus iota beta. What will be the solution? Solution will be, I'm writing it directly, c1 e to the power m1, just substitute it, alpha plus iota beta into x plus c2 e to the power alpha minus iota beta into x, m2 x basically, and the solution eventually finally will be, you just have to remember this final statement, and that is c1 e to the power alpha x cos of beta x plus c2 e to the power alpha x sine of beta x. So that will be the general solution. And again, I'm not wasting time. The logic behind that, from this to this statement, is the Euler's identity or Euler's formula. Euler's formula is e to the power iota theta equals to cos theta plus iota sine theta. The logic behind that, you can also do it by yourself from this to this statement. So directly, if you have distinct real roots, your solution is of the type this. If you have repeated real roots, then your solution is of this type. That's it. In the next video we will do the example.